Good afternoon, everyone. I'm Larry Thiel with Daikin. I've worked with Daikin for 9 years in some of their cutting-edge North American sales and operations, and had the pleasure of watching VRF transform. I've worked in the North American VRF division for 6 years. So I'll give a 15-minute overview of the history of VRF, where we've come from, a global perspective, North American, and then I'll zero in on New York City and what I see today. That's really my main focus right now, is running the New York City Business Development office, driving air source heat pump sales and operations. So this technology was developed in 1982 due to a global energy crisis in Japan. They have no natural resources available, so there's always a premium on peak efficiency and system operating performance. So it was originally intended to be a better way to heat and cool spaces to replace chiller technology, is really what the intent was. Over the years, it's transformed to the point where we've been surprised some of the vertical markets that we hit. This will be geared from a commercial standpoint in general with VRF, but we generally do very well with office, vertical, K through 12, hospitality, and then residential as well. So what we see, and this slide's actually from 2015, so the commercial adoption at this point is 10%, in my opinion, from North America. New York City actually is much further along from an adoption standpoint, probably closer to 15 to 20% of commercial systems installed today are VRF. That's generally due to the design flexibility of these systems and the challenges that we see and that New York City presents. So what we see in every other market in the world globally is there's early adopters, and this technology is launched, and it'll meander along for about 5 or 10 years until it hits about 30,000 outdoor units a year in that market. And that's where you'll start to see it'll get into its growth phase, and you'll start to see exponential growth to the point where it becomes about 40% is what we think the market is globally, and also what we believe North America is getting to now as we speak. So that benchmark of 30,000 systems a year, we hit that in 2016. So I've watched our business double since then. With Daikin standpoint, hopefully Rick can agree, is that to the point where New York City right now, from a total air source heat pump standpoint, it's probably about a $600 million market today per year in just in equipment alone. We expect that to double again in the next 5 years to get to whatever that is, 1.2 billion just in equipment for air source heat pumps. So we're in that exponential growth phase right now. So now's when you see companies like Daikin build a ground-up 4 million square foot facility that's local in Houston, Texas, to be able to reach North American and be able to react quickly to all this growth that we're going to see. So that's an interesting note right there, is that that facility, from a manufacturing standpoint, it was essentially tumbleweeds this time 3 years ago, and now ground up shipping 11,000 air conditioners a day. So from a manufacturing standpoint, that was something that I've never seen in my lifetime. It was just really great to be a part of. This is just a historical timeline to where we've gotten today. The important piece here is the AHRI certification recognition in 2012. So that helps us gather some of this market data, know where we're at, and then also formally rate these systems in terms of efficiency. Refrigerant is essentially a more effective means to transfer heat than, say, water. These water systems, you're going to see large pipes, or air, you're going to see large ductwork, whereas refrigerant, you see small refrigerant lines. So it's a really effective way to use as a heat transfer media. This is just an example of what 200 tons of refrigerant pipe would look like on your left, and then what 20 tons of ductwork would look like on your right. So from a standpoint of maximizing your leasable space, and obviously New York City, every square inch is such a premium, that's where this lent itself really well to be adopted into this market. So the concept is outdoor. It's essentially a split system with outdoor condensing units and then multiple indoor units. And I'll review the indoor units briefly about what some of the options would be. They could be ductless, or 60% of what we sell are also ducted indoor units. It can be air-cooled, and then we also do New York City does quite a bit of water-cooled as well, and tie in with geothermal application. So really flexible as far as how you can use these systems. Also, you have one point of contact from a manufacturing standpoint. A chiller, typical system, there may be 10 different vendor hands into that system, whereas this is modular by design, and typically it's that manufacturer that handles not only the equipment, the piping, and then also the controls. So a heat pump system will have very tight zone control. So at each indoor unit, there's going to be what we call an electronic expansion valve. That has 2,000 to 3,000 pulses in it, so extreme tight temperature control for comfort. But a heat pump system will essentially either be in heating or cooling, not simultaneously. And then we also have what we call our heat recovery system, which you could be in an office and there could be a conference room in cooling while another office would be in heating. So you could have simultaneous operation. Essentially, we can think of it that a heat pump is a two-pipe chiller. So these are essentially chillers that circulate refrigerant instead of water. So a heat pump would be a two-pipe chiller, and I'm going to call the heat recovery system a four-pipe chiller. Each indoor unit has thermistors on it, and we're constantly measuring and sending feedback to that outdoor unit about where we are in terms of set point and how hard we have to work to maintain a comfortable and tight variance. So that outdoor unit is essentially has an inverter compressor in it that will slow down, and that's where you get your electrical savings. The majority of the time, these buildings that we occupy very rarely are at peak demand. They're more often than not within a 40 to 70% profile as far as what actual capacity they may need. So that's where we get the energy efficiency out of these systems, is that they'll slow down and they won't work as hard when you don't need it. So this is the ladies setting a local set point. It's communicating to that outdoor unit, and it's trying to maintain a tight, comfortable variance from set point, and then that's the inverter compressor. That's essentially how we slow down this system and get very good energy efficiency out of them. This is the indoor unit lineup that I spoke of. So on your left there, you'll see our ducted lineup. We have those slim duct concealed. You'll see those in hotels now in the bulkhead. We also have those vertical ducted units. That's a typical unitary air handler that you may see in a residential application or a whatever it may be, condo. And then the concealed duct unit, that's where you're going to see that maybe in offices. And that's our workhorse, that concealed duct unit. On the right side, you'll see the ductless units. There's 2x2, 3x3. So those are usually very flexible as well as far as office application. This is what a local controller would look like, and these are very smart and powerful controllers. You can do setback, you can lock out and make adjustments as far as scheduling, and then minimum and maximum temperature limits, and then after hours runtime setback as well. What is also nice about these systems is that, to me, we create building management systems to control and tighten the performance of these systems, but I can also create a little mini BMS system that, typically the Javits Center would have its own standalone building management systems by Siemens. And, they have a whole team of people working there. But what about that 3-story office in Westchester County or Yonkers or wherever that they wouldn't normally have that budget to be able to build up a whole building management system to really tighten up their HVAC or other systems that they want to tie in. So we create mini BMS systems that bridge that gap as well. And we tie it in a multitude of ways in terms of being able to see it globally, tying in lighting, and then external ventilation equipment as well. So that's part of the story too, is that these systems get really smart in a hurry and not the typical full-blown front-end BMS budget that you would expect. So thank you, appreciate it, and thank you for your time.